In this section, we're going to register and authenticate the user. In order to do that, we need some backend capabilities. That's where our troubles begin. Vue is completely client-side. Every line of code we've written is meant to be loaded on the browser. We haven't had to worry about the backend. Webpack will create a temporary server for us. With that being said, authentication isn't a task that's completely left to the server. The browser or client does play a role in it. Before we can get to authentication, we need a server that will handle authentication. Unfortunately, we don't have the time to go over a lot of the concepts for backend development or even review the code for it. It's a topic that deserves a course of its own. Luckily, there is a solution out there that will solve all our issues. The solution I'm referring to is called Firebase. Firebase was initially as a database. Google acquired it a few years after its release. Google has transformed the product from a database to a backend solution for mobile applications. It doesn't have to be used for mobile apps. You can also use it for web applications. So what do I mean by backend solution? Firebase will store your data, authenticate users, store files, provide analytics, and much more. It saves you time from having to learn another language for setting up a server. It's used by many companies like Twitch, Alibaba, and the New York Times. I find that it's a great solution for quickly prototyping an application. Firebase is more than suitable for powering our application. Even though we'll be using Firebase, we will go over some of the concepts that make authentication work. Before we dig into the code, we'll need to create a Firebase project. It's completely free to create a project. In the resource section of this lecture, I provide a link to Firebase. You will need to log into your Google account to use Firebase. At the top right corner, click the Go to Console button. You will be presented with the option to add a new project. Click on it. A pop-up will appear asking for more information about your new project. We're going to call our project Music. Any name will do, but it should be relevant. We are creating a music app, so it makes sense to call it Music. An ID will be generated for your project. I'm fine with the generated ID, but you do have the option of assigning a custom ID by clicking on the pencil icon. Let's continue on to the next settings. You may be asked if you'd like to integrate Google Analytics into the project. We're not going to use Google Analytics for this project. However, you're more than welcome to enable it if you'd like. I'm going to disable it for this project. There's not much configuration we have to make out of the box. The setup process is an absolute breeze. We can tell Firebase to start creating the project. This preparation may take a while for some of you. Just be patient. Once everything has been prepped, you can proceed to view your application. Right away, you'll be given a full-fledged dashboard for managing your application. It can be overwhelming, but I'll be sure to guide you through everything. The first step we want to take is to create a database. The database is where we can store the user data. On the sidebar, this section is where we'll be spending most of our time in Firebase. This section will list every tool we have at our disposal. These tools will help us develop the application we're trying to build. Firebase will ask us to create a database. We're presented with two options for creating a database called Firestore and Real-Time Database. Firestore is Firebase's new database. It's the better option. It comes with more features and scales better. The Real-Time Database was the original solution the team came up with. It's available for teams that prefer to work with the older version. For this course, we'll be using the Firestore database. Click on Create Database under the Firestore section. A modal will appear to prompt us to select a set of security rules. There are two sets called Production and Test. The Production mode will create a set of strict rules. Only authorized users can read or write to the database. This option is usually the option you want to go with when launching your application. We're currently in the development phase of the application, so the test mode will be better for us. This mode will allow all users to read and write to our database. It's not a secure option, but that's alright. No one knows about our application beside us. When we near the completion of our application, we are going to revisit the rules. We'll make things stricter before shipping to production. Select Test Mode and then click Next. We'll be asked where the database is located. This is an important option to consider. Firebase offers locations all over the world. I recommend picking a location that's close to you or your users. The closer a database is, the faster the response time. By default, Firebase will try to pick your location closest to you. If you don't like the location, then you do have the opportunity to change it to somewhere else. I prefer the default, so I'll leave it as is. Click Done. Firebase will begin creating your database. This creation process may take a few moments. We've successfully created our database. Currently, the database is empty. We'll be filling it with data soon. In the next lecture, we're going to review the rules generated by Firebase. In this lecture, we're going to review the rules generated by Firebase. The rules we selected allow anyone to read or write to the database. It's not an ideal set of rules, but it'll work for the development phase of our application. I want to take a moment to review the rules to understand better what's going on. You can navigate to the rules by going to your project's dashboard in Firebase. On the sidebar, under the Develop section, click the Database menu item. Then, switch over to the Rules tab. Firebase has an editor we can use to modify the rules. You may notice that the syntax is similar to JavaScript's object syntax. Firebase adopts similar syntax, but there are differences. Let's go through the rules line by line. The first thing that's being set is the rules version variable. It's being set to 2. The version must be set before you can proceed to write some rules. The version determines the syntax you may use. Different versions support different features. Version 2 is the latest version. After setting the version, you can start to create the rules. Creating rules is similar to creating CSS properties. I don't mean that syntax-wise. In CSS, you need to make a selection. Once you've made a selection, you can start to add different properties. The properties are applied exclusively to the selection. That same idea is represented here. The first step is to select a resource the rules should apply to. After making a selection, we can begin to add the rules. Rules can be applied universally. In some cases, you may want to apply rules to specific resources in your database. Firebase provides everything you'll need to apply rules to different resources. The second line is selecting a service. I mentioned in the previous lecture how Firebase transitioned from a database solution to a backend solution. Firebase offers various products it calls services. You can have different rules for different services. The service keyword allows you to select a service. In this example, we're selecting the cloud.firestore service. This service refers to the database product. After selecting the service, we're adding curly brackets. Anything inside the curly brackets is how you can group selections or rules. Then, we're using the match keyword. Anytime a request is made to the database, it must be to a specific resource. The match keyword can be used to check if a request is being made to a particular resource. In this example, we're checking if the request is being made to the databases/database/documents resource. The databases directory is where databases are stored. You can have multiple databases for a Firebase application. Currently, we're on the free plan. We're allotted one database. If you'd like to have multiple databases, you'll need to upgrade to a premium plan. We won't need to upgrade because one database is more than enough. Every database is listed under the Databases directory. Afterward, we're using a placeholder called Database. Firestore will replace this placeholder with the name of the database the request is trying to access. If you want to apply a set of rules to a specific database, you'll need to change this to the name of the database. The last segment in the path is the Documents directory. Documents is the terminology for the objects in your database. We'll discuss documents more in depth in a later lecture. Inside this condition, we're making another condition. The condition is checking if the document is equal to 2 stars. 2 stars are treated as wildcards. This wildcard means the rules inside this condition will apply to any document. The last thing we're doing inside this condition is adding the rules. We'll want to have different conditions for reading and writing. Add the following, if true. After making any changes, you will need to publish them. There's not much else going in the rules. The way they're set is fine for now. If we ever do need to modify them, we will. In the resource section of this lecture, I provide a link to the rules documentation page. Everything you'd want to learn about rules can be found here, from the syntax to how you can test rules. I recommend checking it out if you would like to learn more about security rules. In this lecture, we're going to install the Firebase SDK. The Firebase SDK is a library that will assist us with communicating with Firebase's products. SDK is short for Software Development Kit. It'll make our lives easier. In the resource section of this lecture, I provide a link to the installation page for the SDK. This page goes into detail on how you can install Firebase. The SDK can be installed with npm. Let's try installing it. Switch over to the command line. In the command line, run the following command: npm I firebase at 8. After a few moments, Firebase should have been installed. Let's start configuring Firebase into our project. Before adding the configuration, we should ask ourselves, where should we write the configuration? It's possible to configure Firebase directly from the main.js file. On the other hand, I think it would be a good idea to separate the configuration into another file. Separation will reduce clutter in the main.js file. In the includes directory, create a file called firebase.js. You don't have to call it this, but I recommend keeping the name short and relevant. Next, open the main.js file. We'll import the file into the main.js file. Otherwise, the code inside the Firebase file will never execute. Below the import statement for the validation file, import the Firebase module. We can begin to configure Firebase. Switch back to the Firebase file. The first thing we'll do is import the Firebase module. We're importing a specific module from the Firebase library called app. The app module is the core of the Firebase SDK. Regardless of what services or products you plan on using, the core must always be imported. The core module is what will help you with configuring and connecting to Firebase. If we were to omit the app from the path, we'd be importing every Firebase feature. This includes features we aren't actively using or need. This will unnecessarily increase the bundle size of our app. The proper way of importing Firebase is to individually import what we need. The Firebase module is broken up into packages. By passing in Firebase alone, you're telling it to import all of its packages. In almost all cases, you will need to import the app package. This package is the core of Firebase. The rest of the features won't be usable unless you import this first. If you're on version 9 of Firebase, the path must be updated to firebase/compat/app. You can verify the version of Firebase by viewing the package. For those of you on older versions of Firebase, the compatibility path does not need to be added. Otherwise, every time we import Firebase, you should always modify your path to include this directory. The next step is to grab the connectivity details from Firebase. In the browser, navigate to the console for the music project. You should be on the overview page. You can navigate there by clicking on the menu item in the sidebar. At the top of the page, Firebase will ask us to select a platform. We can select iOS, Android, Web, or Unity. We'll want to click on the one that says Web. A pop-up will appear, asking us for more details about our project. It's going to ask us to assign a nickname. We'll give the project the nickname Music. It'll ask us if we'd like to host the app on Firebase. We'll look into that in a later section. Let's leave this option unchecked. We can enable hosting later if we'd like. Let's keep moving forward. After a while, Firebase will spit out a configuration object you can copy and paste. We're not going to copy the entire code snippet. Just copy the Firebase config variable. Go back to the editor. Paste the variable into the Firebase configuration file. Let's go over the object together. The very first property is the API key. The API key is how we'll be able to connect to Firebase. It's how we let Firebase know that we're the ones sending the request and not some other application. The next property is the authentication domain. Firebase will provide us with a URL where we can send the authentication information. It's what we'll need if we want to add authentication to our app. Next, there's the project ID. It's followed by the storage bucket. A bucket is used to describe the location where the files are stored. An application can have multiple buckets, but we're using the free plan, which comes with one bucket. One bucket is plenty for the application we're building. The next property is the sender ID. Firebase comes with a feature to push notifications between applications instantly. We won't be using this feature, but it is there if you need it. I'm going to remove this ID since we won't be using it. Firebase won't throw an error if it's unavailable. Lastly, we have the App ID property. Firebase allows for multiple apps to be connected to a project. We're building a web app. If we added an iOS or Android app, they would be assigned unique IDs. Now that we have the configuration object, we can initialize the app by calling the firebase.initializeApp function. We can pass the configuration object into the function. In some cases, the code snippet you copied from Firebase will try calling the function without accessing it from the Firebase object. If that's the case, update this line to match mine. We're not going to destructure this function. This function will initialize Firebase by connecting to it. It'll return an instance of Firebase we can use to communicate with it. Let's export the instance under the default namespace. This step is important. Otherwise, the instance will not be accessible to our components. Whenever we need to use Firebase, we can import this module. Switch over to the browser to check if everything is working. The page loads normally. There's one last step we'll want to take. Head back to the editor. At the top of the file, import the Firebase/auth module. We're importing the authentication module because we'll be using Firebase to authenticate the user. If we'd like the authentication service to be available, we'll need to import it. I want to point out that we're not assigning the module a name. It's not necessary because Firebase is smart enough to extend the core. It will not export another object for you. We're finished. We've successfully integrated the Firebase SDK into our project. In this lecture, we're going to register the user by submitting their data to Firebase. We're going to need to turn on the authentication feature in Firebase before we can do so. Otherwise, Firebase will reject any authentication attempts we make. Open the Firebase console for your project. On the sidebar, click on Authentication. Firebase will give us the following message. Authenticate and manage users from a variety of providers without server-side code. Nowadays, many platforms allow users to register to other sites by sending their data to the site they'd like to register to. It's quick, easy, and flexible. Some examples of platforms that provide this service are Facebook, Twitter, and Google. These companies are what Firebase is referring to when it uses the word provider. To view the list of providers, we can switch to the Sign In Method tab. Firebase supports multiple platforms out of the box. The method we'll select is the email method. Enable it, but don't enable the passwordless option. We want to be able to store the password. After enabling it, click Save. The status will change to Enabled. We can start adding users to our Firebase application. We'll want to do so through Firebase's API. The next step is to send the data to Firebase. We already have an instance of Firebase that'll help us do that. In your editor, open the Register Form component. Scroll down to the Register function. This function is where we handle the registration submission. We've already taken care of adding the alert messages. We'll use the Firebase instance to send the data. However, the Firebase instance is not available in the component. We'll need to import it. At the top of the script block, import the Firebase instance. It's important that we're importing the Firebase file we created in the previous lecture. We don't want to import the Firebase module mistakenly. They are not the same. One simple trick for making sure you're importing files from the source directory is to use the character. Webpack will replace the character in import statements with the path to the source directory. There are two benefits to this. It saves you from having to move up multiple directories if your files are nested. Secondly, you don't have to update the import statements in the file if you move it to another directory. The import statements will still be able to import the files you want. We are going to use the character in our components whenever possible. Go back to the register function definition. We're going to write the code in between the message alert updates. The first thing we'll do is invoke the firebase.auth function. The auth function will return an object with methods and properties we can use to communicate with the authentication service. In the resource section of this lecture, I provide a link to the Authentication SDK documentation page. Firebase tells us the following. Do not call this constructor directly. Instead, use firebase.auth. In most examples, you will find Firebase creating an object using the firebase.auth function. This function will give you access to the properties and methods listed on this documentation page. The method we'll want to use is called createUser with email and password. Click on it from the list. According to the documentation, it expects the email and password as arguments. The returned value is a promise. The promise will give us an object with the user's credentials if the authentication was a success. The description says the following about the function. Creates a new user account associated with the specified email address and password. On successful creation of the user account, this user will also be signed into your application. User account creation can fail if the account already exists or the password is invalid. This one note is important. Firebase will automatically log the user in if their account was created successfully. We'll want to reload the app if that's the case. Reading further, we'll find a list of possible errors. Lastly, there's an example we can use. We won't use the example they provide. We're going to take a slightly different approach than the default example. Let's go back to the editor. We're going to chain the createUser with email and password function. This function will return a promise, but I don't want to chain the then or catch functions. Instead, we'll use the async await keywords. Before the register function name, add the async keyword. We'll add the await keyword before the Firebase function. The createUser function will send a request to Firebase with the information you've provided it. If successful, will be returned with the user's credentials. We'll want to store these credentials to keep the user logged in. We're going to assign the response to a variable called user credentials. We can't forget about the arguments. We'll pass those in next. The documentation says the first argument is the email and the second is the password. Both values are stored in the values parameter. We are provided the values from the submit event. We don't need to store the values in a data object. We'll pass in both values to their respective arguments. The values from the fields can be retrieved by their names we assigned them. The property names correspond to the name attributes on the field components. With this one function, we're able to completely register the user in the system. In the next lecture, we'll look at handling the response. In this lecture, we're going to handle the response from Firebase. We're using the createUser function to initiate a request. It's possible we may receive an error from Firebase. We'll want to handle the error if that happens. Since we're using async await syntax, we can't chain the catch function. If we want to catch errors, we'll need to use the try-catch block. Surround the asynchronous statement with the try-catch block. The catch block will have a parameter called error. Every error will come with two properties, a code and a message. We're not going to use either. Instead, we'll output a universal message for any error. This is to keep things simple. In the catch block, we'll want to update the alert message. This way we can notify the user their submission failed. First, we'll set the inSubmission property to false. The form doesn't need to be disabled anymore. We'll want to enable it again so that the user can correct their mistakes and submit the form. Afterward, we'll set the alert variant property to bgred500. This value will change the alert box to the color red. Red is usually associated with error messages. The last property we'll update is the alert message. Set the alert message property to the following. An unexpected error occurred. Please try again later. The last thing we'll do in the catch block is to return the function. This return statement will stop the function from executing further. If we didn't return the function, the alert message would display a success message. We'll test this in a moment, but there is a problem with this function. The variable user credentials is inaccessible outside of the try-catch statement. It's because we're defining the variable inside the block, which limits its scope. If we want the variable to be available throughout the function, we'll need to define it at the top. Its initial value will be null. If everything works out, the code inside the catch block will never run. The alert message will tell the user they've successfully logged in. Before we update the alert messages, we'll log the user credentials variable to verify the user was registered. Let's test things out. Open the app in the browser with the console opened. Try registering an account without triggering an error. I'll receive a success message indicating that everything worked. In the console, information about the user's credentials is logged. We'll look at this information later when we want to authenticate the user. This verifies everything works, but let's double check. Firebase will store the user for you. Open the Firebase console in another tab. Navigate to the Authentication page. Under this page, the user should be listed. If you don't see anything, you may want to refresh it by clicking on the refresh icon. We'll find the user we created. Firebase will even generate a unique ID for our user. We've successfully created a user. Before we move on, let's test if the error works. Switch back to the registration form. You will need to refresh the page. We'd need to refresh it because we've disabled the form if the registration was a success. After refreshing the page, try submitting the form again with the same information. Firebase will reject the registration because duplicate emails are not allowed. The alert message will be the color red with the message. An unexpected error occurred. Please try again later. Fantastic! We're able to register the user by using a single function. Firebase handles the rest by sending the request, validating the information on their end, and then providing us with a response about the user's credentials. The only thing we have to handle is the response. By using Firebase, we don't have to worry about the back-end logic as much. With a few clicks, we have an authentication system ready for us out of the box. In this lecture, we're going to refactor our configuration of Firebase by exporting services. We're going to be using additional services by Firebase. We're already using one service, which is the Authentication service. The Authentication service by Firebase does not store additional information about the user. It stores the email and password. That's about it. We aren't able to store their age, country, or name. We won't be able to store it in the Authentication service. If we'd like to store additional information about the user, we'll need to store it in the database. Firebase has another service called Firestore. It's the name of their official database. The Firebase SDK comes with a module for interacting with the Firestore API. The functions for interacting with the database can be enabled by importing the package. We're going to open the Firebase file in our editor. Every service by Firebase is broken up into packages. We've imported the authentication package to enable the methods for authentication. If we'd like to enable the methods for interacting with the database, we'll need to import the Firestore package. We'll import it without assigning it a variable. It's crucial we import the Firestore package and not the database package. If you were to read the documentation, you might come across the database package. The database package is for the real-time database service. It's a package for the old version of the database. For this course, we're using Firestore, which is the newer database. Importing the Firestore package will assure us that we have the correct methods and properties for interacting with the correct database. We don't have to import the database package because we're not using the real-time database. It's not required to assign the package to a variable. Firebase will extend the Firebase object. The next step is to refactor the code. I'm going to switch over to the register form component. In the register function, we're invoking the firebase.auth function to access the authentication service by Firebase. We'll have to repeatedly call the firebase.auth function if we want to use the authentication service. That's not very efficient. It would be better if we created a reference to the service. We'll want to do the same for Firestore. We're going to use the database frequently throughout this course. Creating a reference will make our code more readable. Switch back to the Firebase file. We're going to create references to the Authentication and Firestore services. Then, we'll export the references. This will allow for any component to access a service without having to create a reference itself. We'll begin by removing the export default keywords. Instead of exporting a default object, we're going to use named exports. We'll still want to initialize Firebase with the initializeApp function. This will not change. After initializing the app, we're going to create a variable called Authentication. Its value will be set to the object returned by the firebase.auth function. Create another variable for the database reference. Its value will be set to the object returned by the firebase.firestore function. The Firestore function will return an object with methods and properties for interacting with the database. Rather than repeatedly calling it, we'll store it in a variable. This will make our code more readable. We're finished creating the references. We'll want to export them. Both variables will be exported as named exports. We're using named exports because it's easier to destructure in an import statement. This will break the app because the register form component is expecting the Firebase object when it's not being exported anymore. We'll need to update the component. Switch over to the register form component. Scroll to the import statements. Update the import statement for the Firebase file. Destructure the object for the authentication reference we exported. We'll update the register function next. Instead of calling the firebase.auth function directly, We can replace this line with the auth reference we imported. Great, we've successfully refactored our code base. We are creating references of our services. This makes our code more readable. We'll continue with storing the user's information in the next lecture. We can move on to inserting the form data into the database. We'll continue working in the register form component. At the top of the script block, we'll destructure the Firebase module for the database object. It's time to add data to the database. The first step for inserting data into the database is to select a collection. Let's discuss some terminology. There are 3 words you're going to hear me throw around. You may find these terms used frequently in the documentation. It's important we take the time to understand what they mean. The first term is bucket. We've already talked about buckets when we created the Firebase application. I want to recap what it is quickly. A bucket is a physical location where your data is stored. Firebase allows you to create multiple buckets if you're on a premium plan. You may want to do this if you want to keep certain data separate. We don't need that kind of flexibility at the moment. We can keep everything contained in one bucket. The second term is collection. Collections are objects in Firestore. They give you a way to organize data. You can think of them as categories. You don't want your data to get mixed with one another so carelessly. It's better to organize data into separate objects. We'll be able to filter and sort through them. For example, you can have a user's collection for storing user data. You can have another collection for blog posts, settings, song uploads, lyrics, etc. Firebase requires you to select a collection before performing any actions on the database. You cannot add data to the database until you choose a collection to add it to. The last term is documents. Documents are the individual records in a collection. It's the data you store in the database. Multiple documents can be stored in a single collection. We'll be mostly working with documents and collections in this course. We're going to select a collection in the Firebase file. We could do this in the register form component file, but we'll be working with the user's collection in multiple components. It's better to export the user collection so that it's accessible in all components. Below the variable definitions, I'm going to create a variable called user's collection. Its value will be the object returned by the db.collection function. The db.collection has one argument, which is the name of the collection to select. We currently don't have any collections in the database, but that's alright. The collection doesn't need to exist for Firebase to select it. We're going to call the collection users. This function will return an object with methods and properties for working with the user's collection. The next step is to export this collection. We'll have access to the user's collection in any component. Switch back to the register form component. In the import statement for the authentication object, we're going to change the DB object to the user's collection object. We only need the user's collection object. The purpose of importing the database object was to select the user's collection. However, we're already doing that inside the Firebase file. It's no longer necessary to have it imported. Back in the register function, we're going to use the user's collection. We'll call the add function. The add function will add a document to the collection. A document is the terminology used to describe an object inside a collection. The add function has one argument, which is the object to insert. We're going to pass in an object with the user data. We're not going to pass the values object directly to the function. We don't want to insert the password, confirm password, and TOS properties to the database. We can omit these. The password is already being stored in the authentication section. The TOS property was to ensure the user agreed to the terms of service on the front end. Otherwise, they wouldn't be able to submit the form in the first place. We won't bother storing that type of data in the database. Let's add the name, email, age, and country properties to the object. The add function will return a promise. We're going to use async await syntax to make our code readable. Add the await keyword before the function call. We'll want to handle the error next. Wrap the request with a try-catch statement. In the catch statement, we're accepting the error parameter. We're going to use the same code we used for handling the authentication request. Copy and paste the code over to the new catch block. We're finished. By using the add function, we're able to insert additional information into the database. It's data we can't typically store in the authentication service. However, we are storing the email. Even though the authentication service already stores it, it's still handy to store it in the database. This will allow us to filter and sort through the data by email. Let's try testing if this works. We'll switch over to the browser. Make sure your developer tools are opened. We want to check for errors in the console. After verifying there aren't errors in the console, fill out the registration form with valid values. After submitting the form, we will receive a success message. The console will continue to log the user's credentials information without a problem. We'll want to verify if the data is inserted into the database by checking the Firebase console. In the Firebase console, navigate to the database page. If you already had it opened, then you should see the data because the database refreshes itself. If not, try manually refreshing the page. In the database, we'll find 3 new columns. On the left, we have a list of collections. Before submitting the request, there were no collections. By adding a document to the collection, Firebase will check if the collection exists. If it doesn't, it'll create it for you. We didn't have to take care of that ourselves. In the middle column, we have a list of documents in the collection. Documents are objects in a collection. In the right column, we'll find the data stored in a specific document. You can click on any of the documents to view its data. This collection is where we'll find the form data we submitted. All our data is present and accounted for. If we were to look at the name of the document, it's a random string. The random string is a generated unique ID for our data. This is important to understand. Databases need a way to track each individual record. This will allow us to pull a specific record or user if we ever need to. We could have provided an ID ourselves, but Firebase will create one for you if you don't provide one. We're going to let Firebase take care of assigning IDs for us. In this lecture, we're going to discuss how authentication works. The next step for our application is to authenticate the user after they've registered an account. This step is entirely optional. It entirely depends on the needs of your project. However, you'll find that most apps will log you in after creating an account. It's a common user experience. We're going to implement this experience for our users. Before we get into that, let's understand how authentication works behind the scenes. First things first, we have to view our project as 2 different applications. We have the View application we're building, and then we have Firebase. Authentication is mostly handled on the server. In our case, this would be Firebase. Firebase can take care of hashing the password, sending a confirmation email, or storing the user's data. As front-end developers, we don't have to worry about these kinds of things. The role of the front-end is relatively simple. We send the login data to the server responds with a token, and then we store that token. There's not much else for us to do. Authentication tends to be the same across many back-end solutions. Even though we're using Firebase as our server, you can apply this process to almost any backend, regardless if it's PHP, Node, or some other programming language. Let's break down the authentication process step by step. The View application will send the user's login data to Firebase. We're already familiar with this step. We performed it at the start of this section. Firebase will take care of authenticating the user. It'll check if a user exists with the credentials we sent over. If the authentication is successful, Firebase will generate a token. The token is what's sent back as the response. Tokens typically come in the form of a unique string. It's essential we store this token. There are various methods at our disposal. The method we'll be going with is local storage. Local storage is a web API that comes with your browser by default. It's not specific to Vue. Once we've stored the token, we can send it to Firebase whenever we want to store or update data related to the currently authenticated user. The token will be used to verify the user. Since tokens are unique, we won't have to worry about a user's data being manipulated without their permission. We don't need to resend the authentication info again. The token will suffice. This is just an overview of how things work. I'll get into specifics later in this section. It may seem like a lot to do, but it's rather simple and easy to implement once you see how it's done. The overall process I'm talking about is called stateless authentication. You may have heard of this before. If not, that's fine. In the case of traditional applications, something called sessions is used to keep track of who's logged in. Sessions are stored on the server. The server actively knows who is logged in. When the server keeps track of this, this is what's called stateful authentication. However, in our case, Firebase will not keep track of who's logged in. Instead, we're going to use tokens to verify the user. For every request we send, we will also send the token. The token will be used by Firebase to confirm that the user is who they say they are. Because the server doesn't keep track of who's logged in, this is what's called stateless authentication. It's very common to implement stateless authentication for single-page applications. While sessions are still practical, it's much easier to work with tokens. We'll need to make a minor modification to the security rules before we move forward. Currently, I'm in the Rules section for the Firestone database. Pause the video if you need to navigate to this page. As it stands, anyone is allowed to interact with the database. They can even delete the entire database if they wish. We don't need to keep the same rules anymore. It's dangerous to allow anyone to have this much power. We want to restrict who can read and write to the database. Nested deeply inside the rules, the same condition is being used for read and write permissions. We'll want to have different conditions for reading and writing. For reading, we'll allow anyone to view the data. For writing, we'll restrict permissions to authenticated users only. We'll empty out the block completely. Add the following. Allow read if true. Allow write if request.auth.uid equals null. The first line will allow anyone to read the database. We aren't going to store sensitive data such as passwords. It's alright if the data is accessible. As for the writing permission, we're using an object called request. Firebase will define this object for you. We don't have to do anything to receive it. We can use it to learn more about the user who's trying to access the database. If we have the authentication service turned on, we'll be able to access information about the user who's currently logged in. In the resource section of this lecture, I provide a link to the authentication object. According to the documentation, every authentication object will come with a UID and token property. The one we're using is called UID. If the user is not authenticated, this will be set to null. Back on the rules page, we're checking if the UID property is not equal to null. If this condition returns true, then the user will be able to write to the database. Otherwise, they'll be denied access. We're going to publish the rules. Before doing so, make sure your rules match mine. We're finished with modifying the rules. In the next lecture, we'll begin authenticating the user into the application. In this lecture, we're going to log the user in after they've registered. The registration is taken care of in the register form component. In the register function, we're using the create user with email and password function to create the user. It's also authenticating the user if their account was successfully created. The response from the function will be the user's credentials. We're storing the returned value in a variable called user credentials. We don't need to do anything with the variable. In the previous lecture, I discussed how we'd need to store the token returned by the authentication functions. Luckily, since we're using the SDK, that's taken care of for us. Firebase will store the token on our behalf. In addition, it'll send the token if it's available to any service that needs it. This includes Firestore. Below this, we're making a request to the database to insert the form data. We recently changed the rules to restrict writing permissions to authenticated users. The Firebase SDK will send the token along with this request. The code will continue to work as it did before. Let's try testing that out. In the Firebase console, navigate to the Authentication section. We're going to delete the user we've already registered. This is so we can start fresh. All the way to the right, click on the drop-down button. Delete the user from the app. Next, navigate to the database. We're not going to delete the collection. We want to delete the document. Documents can be deleted on the right column. At the top right corner, click the drop-down to delete the document. We're ready to test the registration. Open the app in the browser. Try registering a new account. We can successfully create an account. We didn't have to modify the code because Firebase sends the token to the database on our behalf. This process is the most significant benefit of using the Firebase SDK. It'll store the token and send it for us. There is one important point I want to make clear. Back in the register function, we're registering the user in the authentication service before we insert them into the database. We must perform these sequences of actions in this order. The token will not be available until the user is authenticated with the authentication service. If we were to swap the order, Firebase would throw an error because the user does not have permission to write to the database. We're going to make one more modification to the register function. Even though Firebase is keeping track of everything for us, we will store a Boolean value in the state to keep track of if the user is logged in. Let's look at our app in the browser for a moment. If we were to look at the navigation menu, we have a link for logging in. However, if the user is already logged in, then we'll want to change this to say log out. We can toggle the links by keeping track of the user's current authenticated state in the store. Switch over to your editor. In the store directory, create a new file called user.js. For this demonstration, we're going to create a new store for users. It's completely possible to create a single store. However, it's common practice to organize the state into separate stores for better management. In this file, import the define store function from the Pinia package. Next, export this function from the default namespace. The ID of the store will be called user. Pass in an object. In this object, define the state function. Lastly, add a state property called user logged in with an initial value of false. The next step is to toggle this property after the user successfully registers an account. Back in the register form component, we're going to update the register function. First, the store needs to be imported and registered with the component. At the top of the script block, import the map-writable state function from the Pinia package. We're going to update the state of the component. Therefore, we are importing the writable function to allow us to do so. Next, import the user store with the following name, use user store. We've got everything we need. Time to register the state. Inside the component's exported object, add the computed object. Within this object, call the map-writable state function with the spread operator. Pass in the useUserStore variable as the first argument. The second argument is an array of state properties to map the component. Add the userLoggedIn state property. It's time to update this property. The state should be updated after the user has been registered. I'm going to update this property before updating the alert message. Set the userLoggedIn property to true. As simple as that, we've authenticated the user into our application. Firebase handles most of the complexities. On our side, we just need to keep track of the user's authentication status with a Boolean value. Let's give this a test. Open the Firebase console. Delete any users in the Authentication service or users collection. We want to start fresh one more time. Then, try filling out the registration form in the app and submit it. We will receive a success message. Great! We are successfully keeping track of the user's current authenticated status in the state. In this lecture, we're going to take a step back to discuss designing our state. The reason we're going to discuss this topic is because we're going to refactor our code with actions. We've successfully registered and authenticated the user. The code we've written is isolated in a single component. In some cases, you may want to register a user in multiple locations. For example, you may build an admin interface for managing the application. This admin interface may include a feature for creating accounts. It isn't uncommon to build such a feature. In those cases, it would make sense to make the code more reusable. Currently, if we wanted to create an account in another part of the application, we'd have to rewrite a lot of the code. Pinia comes with a solution called Actions. Actions are functions for outsourcing business logic in the store. Simple as that. We can define functions in a store. These functions will become available to all components. If you are familiar with Vuex, Pinia has a different approach to actions. From actions, we can perform mutations. This feature is completely different from other state management libraries where mutating the state is disallowed. There are advantages to using actions. Firstly, they are available to all components. In the register form component, any methods defined in the configuration options are isolated to the component. They can't be used elsewhere unless we pass down the methods as props. By using actions, they can be exposed to any component. Another advantage is that actions can be asynchronous. Since actions are not logged, there isn't a reason to keep track of them. Lastly, actions can commit multiple mutations. This can help reduce the amount of code you have to write. One last thing before we get into writing action functions. I want to make it clear as to when you would want to define an action instead of defining a method inside a component. Here's a general rule of thumb. If the code you write will affect the state, you'll want to write it as an action. Otherwise, define it as a method for the component. For this reason, we're going to refactor the code we've written for the registration form. We'll start the refactoring process in the next lecture. In this lecture, we're going to refactor our code base with actions. Currently, I'm looking at the register function we created in the register form component. Two requests are being made inside the function. One request is for the authentication service. Another is for the database. Both requests are necessary for registering the user. Aside from this, the rest of the function updates the properties for the alert messages. The code we've written in the function can be broken down into two parts. There's the logic for manipulating the component, and another for manipulating the state. We should separate this logic. The code for manipulating the state will be put into an action function. We'll leave the rest inside the component. Let's begin using action functions. Switch to the store file where our state is managed. Inside the exported object, we're going to add a property called actions. The actions object is where we can define action functions. Inside this object, we're going to create our first action function. We'll call it register. On this function, add the async keyword. We're going to perform asynchronous requests inside the function. In addition, I'm using a regular function, not an arrow function. The developers of Pinia recommend regular functions for one reason. The this keyword gives us access to the state. If we were to use arrow functions, we would not be able to interact with the state from our actions. The register function will make a request to the Authentication and Firestore services. We've already written the code for making these requests. We can copy them over to this function. Switch to the register form component file. The requests are made in the try blocks. Cut both pieces of code inside the try blocks. Paste them over to the register function in the store. Here's what you should have. In the register action function, we're calling the create user with email and password and add functions. We're going to remove the assignment to the user credentials variable because we don't need to log it anymore. If you're using Visual Studio Code like me, you may be receiving errors because the authentication and users collection objects are not defined. We'll need to import them. We can copy the import statements from the register form component. Switch back to it. Cut and paste the import statement over to the store file. There's one last thing we will copy over to the register action function. In the register function for the register form component, cut the line of code where we update the user logged in state property. Paste it at the very end of the register action function. Like I said before, we can access the state of a store from within an action by using the this keyword. The next step is to update the argument values inside both functions. If we look carefully, we're attempting to access the values object from the component. However, we're not in the register form component. We don't have access to this data property anymore. We'll need to pass them on to the register action function. Action functions must be mapped to a component before they can be called. Switch to the register form component. First, we're going to clean things up a bit. There are two empty try blocks. We don't need both of them. We're going to remove the second try catch block altogether. The variable user credentials is not being used anymore. We can remove the variable definition and the log statement. Time to map the action. At the top of the script block, replace the map writable state function with the map actions function. Since we're not manipulating the store from within the component, we don't need the function for writing to the state. The map actions function will assist us with mapping the action functions to the component. In the computed object, replace the map writable state function with the map actions function. In the second argument, the array must contain a list of functions to map to the component. There's just one problem. The name of the function in the store conflicts with the name of the register method from within the component. Luckily, the map actions function supports aliases like the other mapping function. Replace the array with an object. The alias for the register function will be called createUser. Before calling this function, actions are not meant to be mapped to the computed object. Instead, they must be mapped to the methods object. Move the map actions function from the computed object to the methods object. We can safely remove the computed object from the component's configuration options. Let's scroll to the try block. Inside this block, call the this.createUser function with the await keyword. We can pass on data to an action function like we would any other function. Let's pass on the values argument. Let's accept the data being passed into the function. Back in the store, update the register function's argument list to accept the values argument. We've successfully created an action function that will register the user in both the Authentication and Firestore services. It's accessible to every component in the application by using Pinia's mapping functions. We've refactored a lot of code so far. Head on over to the browser. We'll register a new user into the application. We'll want to check the Firebase console to verify that the user was created. Let's switch over to the database and refresh it. We'll find a new document in the users collection. It has the same information I've inputted into the form. Great. Let's head back to the user store file. There's one thing I want to mention about the action function. You'll notice I'm not wrapping the requests with a try-catch block. While it's not necessarily wrong to handle errors in an action function, we don't need to in this case. We can let individual components handle it. This strategy allows for more flexibility. If components need to handle errors differently, they can. That's all there is to it. By using actions, we have a reusable function for registering the user. The register action is available globally to every component in the application. Hopefully, I have convinced you to use actions. The best part about actions is that they're reusable. If we had an admin dashboard, we don't have to worry about writing the request twice. We can dispatch the action as we did in the register function. So far, we've done a lot to get the user authenticated. There are still some issues we'll need to address before we can move on to the login form. One of those issues is connecting the user with their data. In Firebase, we're storing the user's information in two separate services, the Authentication and Firestore service. At the moment, we don't have a way to connect the two. We don't know which document belongs to which user in the Authentication service. There is one common value between the two services. That would be the email. I don't recommend using the email to keep track of the user. It's because emails can change. If the email changes, we'll have to change the email in the list of users and the database. We want something that'll be consistent once the user has registered. Luckily, there is a value we can use. Navigate to the Authenticated section in the Firebase console. Every user is assigned a user UID. This value is unique. It will never change. We will want to store this value in the database to know which piece of data belongs to which user in our Firebase application. Likewise, Firestore will assign a unique ID to each document. Navigate to the database in the Firebase console. Select the users collection if it hasn't been auto-selected already. In the middle column, we'll find a list of random strings. These are unique IDs assigned to each document. The ID is automatically generated for us. We'll want to change this. Instead of using a randomly generated ID, we're going to use the ID assigned to the user in the authentication service. Before we get started, I want to make one point clear. This issue is a Firebase-related issue. It is not a Vue issue. Storing the user in the database and keeping track of their data is something a back-end developer has to worry about. As front-end developers, our responsibility is to send the data to the correct endpoint and storing the token we receive from the backend. The token permits us to interact with the database. Other than that, everything else is backend related. However, with that being said, I still want to show you how to accomplish this task with Firebase. Some of you may want to use it as your backend solution. That's fine. Even if you decide to use a different backend, the process on the front end is still the same. Alright, let's get started. We'll start by modifying the request to the database. We made that request inside the store file. We'll scroll to the register action. There are two steps we'll need to make. Firstly, we'll need to retrieve the ID generated by the authentication service. Secondly, we'll update the request to store the user's ID. In the resource section of this lecture, I provide a link to the function we used for creating the user. The documentation will help us with finding the information we need. We already know that the function returns the user's credentials. If we scroll down, we'll come across a section of what will be returned. It's an object called user credential. Let's click on the link to find out more about the returned object. It'll tell us that the object, user credential, will have 4 properties. The one we care about is the user property. We'll click on the link again for more information. This page is where we'll find the information we'll need. The user object comes with properties for reading and interacting with the user in the service. Under the list of properties, the one we'll need is called UID. If we click on it, it'll tell us the following: the user's unique ID. This property is exactly what we're looking for. To be clear, this is the ID assigned to the user in the authentication service. We're going to save this ID in the database. Let's switch back to the editor. We'll be working in the register action. For the first request, we're going to assign the function's return value to a variable. The variable will be called user credentials. We're finished with step 1. The second step is to update the request to the database to use the ID. Firebase has 2 functions for inserting the data into the collection. We're using the first one. The add function will insert a document into a collection with a generated ID. It doesn't allow you to generate an ID yourself. If you'd like to use a custom ID, then you'll need to use the other function. The second function is called set. We aren't able to use the set function because it's not available through the collection. If we'd like to use the set function, we'll need to select a document first. Let's look at what the code looks like, and then I'll explain. In the second request, before we call the add function, chain a function called document. The document function allows you to select a document in a collection. However, the document does not exist because we're trying to add it to the database. That's perfectly fine. The document function will create the document if it doesn't exist. This function gives us the opportunity to assign an ID to the document. It has one argument, which is the name of the ID. We'll pass in the following: user credentials.user.uid. Firebase will store the document with the ID we passed in. The ID is not the only thing we'll want to change. The document function returns the document. The object does not come with a function called add. Instead, we need to change this to set. The set function will add or modify existing properties in a document. The argument is an object of changes we'd like to make. We don't need to make any changes to the object being passed in. This will still work. Before we test things, I want to perform one more task. I haven't been completely honest. The authentication service can store additional information about the user, but it's limited. Every user registered comes with a profile. There are 2 things you can store in the profile: a display name and a profile image. We'll store the display name in the service for example purposes. After storing the user in the collection, we'll call a function called usercredentials.user.updateProfile. It has one argument. It's an object of properties we'd like to update on the profile. There are 2 properties we can update on the profile: the display name and profile image. We won't have a profile image, so we'll set the display name property. This task is asynchronous. We'll add the await keyword before it to wait for the response. Let's give things a test. On my end, I'll receive a success message. If I were to inspect the console, I wouldn't find any errors. Fantastic. Let's verify things in Firebase. Navigate to the Authenticated section. In the Authenticated section, we'll find the newly created user. Take note of the ID assigned to the user. It should match the ID assigned to the document in the database. Let's switch over to the database to check if that's true. Plainly enough, the IDs match. Everything works like we wanted it to. We've successfully connected the user's data in the database to their authenticated account. The very last thing we want to do before moving on to the login form is to persist the authentication. After a user registers an account, they're automatically logged into the system. The token is stored locally on the system. The Firebase SDK handles that. We've also taken the time to create a state property. The problem we currently face is that if the user refreshes the page, then they're no longer authenticated into the app. At the end of the day, Vuex is plain JavaScript. Any data stored in the store will become lost if the user navigates away from our site. The user logged in state property is set to false. This value is not what we want. We want to be able to log the user back in if they come back to the application. We can use the token generated by Firebase to help us solve this issue. Firebase will keep track of the token for us, even if the page refreshes. We can use it to tell the Vue application to set the state property to true if the user is logged in. Here's how we'll solve this problem. First, we'll need to load Firebase before we load Vue. We can't check if the user is logged in if Firebase hasn't been initialized. The second step is to check the token after the Vue application has been initialized. If the token is valid, then we'll set the state property to true. We'll take care of the first step in this lecture. Let's begin. Open the main.js file in your editor. The first step is to initialize Firebase before we initialize the app. The app is initialized in the main.js file. We're going to modify it to wait for Firebase to initialize first. Specifically, we want to wait for when the authentication service is ready. Behind the scenes, Firebase will make a request to the authentication service. It'll check if the user is logged in. After receiving a response, Firebase will fire an event we can listen to. We'll want to listen for that event. It'll tell us if the user is logged in. First, we'll need to update the import statement for the Firebase file. Previously, we were importing the file without assigning the import a reference. We'll want to update this to grab the authentication object. The authentication object is how we'll be able to listen for the event. These structure the import statement for the authentication object. The next thing we'll do is listen for the event. We're going to add the code before we initialize the Vue application. Using the authentication object, call the method authStateChanged. This method has one argument, which is the callback function to call when the event is emitted. We'll pass in an arrow function. Firebase will emit the event whenever the user's authentication state changes. This includes when the user is logged out. It'll run immediately after Firebase is loaded on the page. It's guaranteed to run at least once. This event makes it safe to place the Vue instance inside of it. We're going to cut the new instance of Vue and paste it into the callback function. There is one problem with this approach. The event can be emitted multiple times. We don't want to initialize Vue every single time. We can prevent this issue from occurring by using a variable. Before the event, define a variable called app. We won't assign it any type of value. Then, inside the callback function, create a conditional statement that checks if the app variable is empty. We'll cut and paste the Vue app into the conditional statement. Lastly, we'll set the app variable to the createApp function. By storing the application in a variable, we can check if the app has already been initialized. If it already has, we won't need to initialize it again. This takes care of the first step. We've loaded Firebase so that we can check if the user is authenticated when the application starts. The next step is to check if the user is authenticated after the application is initialized. We'll take care of this step in the next lecture. In this lecture, we're going to persist the user authentication. Previously, we waited for Firebase to initialize. At this point, we can check with Firebase if the user is logged in. We're going to perform this check in the earliest phase of our application. The app component is considered the root component. This component is the first component that's initialized. Open the app component file. First, we're going to need the state. Import the map writable store function from the Pinia package. Next, import the user store. Inside the component's configuration object, add the computed object. Call the map writable state function with the spread operator. Pass in the user store. Lastly, add an array with the user logged in state. Overall, we're mapping the state to the component. These are steps we've taken before. It's time to start checking the authentication status of the user. Inside the exported object, we're going to define the created method. This lifecycle function is called when the component is created, as you learned in a previous lecture. In this function, we're going to perform a conditional statement. The condition will check if the user is logged in. If they are, we'll update the state. Otherwise, we won't do anything. At the top of the script block, import the authentication service from the Firebase file. This service will help us detect the authentication of the user. Back in the lifecycle function, add a conditional statement. Next, set the condition to the following: auth.currentUser. The current user property holds information about the user currently logged in. If they're not logged in, it'll be set to null. If the variable is an object filled with properties, this will evaluate to a truthy value. The last step is to set the user logged in state property to true. Within the conditional statement, update the state. Let's check if everything is working. Open the app in your browser. We'll start by refreshing the page. The app will start normally. It won't start until the Firebase event we're listening for is fired off. The event is emitted immediately after the page loads. We don't have to worry about the app never loading because we're guaranteed that the callback function will execute at least once. Open the developer tools if you haven't already. Under the View panel, a new tab should be available called Pinia. This tab contains a complete list of stores within our application. As you can see, the modal store is available. If you can't find the user store, that's perfectly fine. Chances are you're not logged into the application. I'm going to quickly register an account. Next, I will refresh the page. If we look at the developer tools, the user store has been added. Taking a closer look, the user logged in state property has been set to true. Let's refresh the page. Great! We can refresh the page as many times as we want. We'll always be logged in. Let's try testing if the opposite is true. During the authentication process, Firebase will store a token on the client. You never have to worry about the token because it's managed for you by the SDK. However, that doesn't mean you don't have access to it. In the developer tools, switch to the application panel. The application panel allows you to view the metadata of your application. This includes things like storage, service workers, or the manifest document. We're interested in viewing the storage for the application. On the sidebar, there are various storage solutions. Firebase uses IndexedDB. Under this storage, we'll find the Firebase local storage. Click on it. Firebase will store the user's information under a key called Firebase Auth. Under the value column, there's an extensive list of properties. This location is where Firebase is storing the user's authentication information. We'll want to remove this to start with a clean slate. Without a token, Firebase will not be able to verify the user is logged in. It'll default to saying the user is logged out. We have two ways of clearing the data. We can select the row and then click on this button that says Delete Selected. Alternatively, we can switch to the Clear Data tab under the Application section in the sidebar. This tab will give you an overview of the data stored from the application. Scrolling down, you'll come across a button to clear the data. Click on it. I prefer to clear the entire data just in case I miss anything. It'll altogether remove any data associated with our application. After doing so, let's refresh the page. The app loads normally. We'll switch to the View panel to view the mutation logs. Unlike before, the user store may not appear. Alternatively, if it does, the user logged in state property should be set to false. This is because we removed the user's data from the storage. Firebase is unable to authenticate the user. Henceforth, the state does not get updated. That's exactly what we're looking to accomplish. We've successfully created an application that persists the user's authentication. We've completed the registration form. After 10 lectures, we were able to register the user, store their data, and persist their login. It took a lot of work, but it's well worth it. In the next lecture, we're going to work on the login form. When you're ready, I'll see you there. We're finished with the registration form. The next thing to tackle is the login form. A lot of what we'll be doing is the same as before. Unlike last time, I won't draw this out into about a dozen lectures. We'll fly right by this. We'll start by opening the login form component. As you may recall, we separated the forms into separate components for easier management. In the previous section, we've taken care of validating the login form. The next thing to take care of is to send the login data to Firebase. The logic for performing a login will be outsourced into an action. From this component, we are going to run the action function. Let's prepare the component before defining the action function. At the top of the script block, import the map actions function from the Pinia package. Next, import the user store with a name called useUserStore. Let's map a function called Authenticate. This function doesn't exist, but that's perfectly fine. We're just trying to prepare the component. After preparing the component, we'll define this function. Inside the methods object, run the map actions function with the spread operator. Pass in the user store. Lastly, in an array, add the authenticate function. We can call this function from within the login method. After updating the alert message, let's call the this.authenticate function with the values argument. The values argument is where we're keeping the email and password input values. This argument is provided by the vForm component when the form is submitted. One last thing, we'll add the await keyword before dispatching the action. The action we're going to write will have asynchronous code. We want to wait until the action is complete. Make sure the async keyword is added before the name of the function. Just in case, we're going to wrap the dispatch with a try-catch block. If an error occurs, we'll want to handle it. Inside the catch statement, we're going to update the login in submission data property to false. We'll update the login alert variant property to bgred500. Lastly, we're going to update the login alert message property to the following message: invalid login details. Be sure to return the function to stop the function from further execution. We won't need to make any more changes to the login form component. We'll next move on to the store file to define the action. Inside the actions object, define the authenticate function. Since we'll be making an asynchronous request to Firebase, the function should have the async keyword before it. We are being passed down data from the component. We'll want to accept it. Add the values argument to the function. The function will be straightforward. There are two tasks we'll perform. First, we'll send a request to Firebase with the payload data. If the request is a success, we'll want to commit a mutation to log the user in the state. Inside the action, call the function auth.signin with email and password. I'm introducing a new function. It comes with the authentication object we imported. It'll sign the user into the application with their email and password. It has two arguments, the email and password. These exist within the payload. We'll set the arguments to their respective payload values. This request is asynchronous. We'll need to add the await keyword before calling the function. If the function successfully authenticates the user, we can toggle the user logged in state property to true. Otherwise, the function would throw an error. The next line of code would never run. We're done. We don't have to wrap the asynchronous function with a try-catch block because it'll throw an error if the authentication was unsuccessful. Errors will stop the function from executing further. Let's try giving things a test. Before you do, I recommend clearing the site data to start with a fresh slate. In the Chrome Developer Tools, navigate to the Application panel. On the sidebar, there will be an option to clear the storage. Click on the Clear Site Data button. Once you've got that settled, refresh the page. Then, try logging in with an account that doesn't exist. We'll receive an error message. If we look in the console, an error will be logged from the request sent by the Firebase SDK. In addition, we should check the mutation log. The action did not commit the mutation because the request threw an error. Even though we didn't return the function ourselves, the error stopped the function from executing further. Now let's try logging in with valid credentials. We will receive a success message. If I were to refresh the page, we'd continue to be logged in because Firebase stores the token. It'll take care of verifying if the user is logged in afterward. That's great. We've successfully created a login and registration form. After confirming everything, pat yourself on the back. We've had to do a lot to get this working. I know we flew right by this pretty quickly, but this shouldn't be anything new. Almost everything was the same except for the function for signing the user in. In the resource section of this lecture, I provide a link to the Sign In with Email and Password function. I recommend checking it out if you'd like to learn more about it. Registering and logging a user in is one major part of the application. Another major part is to log the user out. Currently, the user will stay logged in until their token expires. The user may want to log out earlier, so we should give them an option to do so. The template I provided you comes with a primary navigation menu. On the left, we have the login and register links. If the user is logged in, we'll want to hide this link. There's another link called Manage, which we'll want to render if the user is logged in. As for the logout link, we'll add it in when the user is logged in. Accomplishing this won't be difficult. The vif directive will help us perform this task. Before we get started, let's make one minor adjustment. We're going to refresh the page if the user successfully logs in. There's no point in having the authentication modal around once the user is logged in. In addition, it'll help us verify that the authentication state persists across page refreshes. We'll start with the Register Form component. Open it in your editor. At the end of the register method, we're going to access the window.location object. This object is a global JavaScript object that's not specific to Vue. The browser defines it. It comes with a method called reload that we'll want to call. The reload method will refresh the page. We'll do the same inside the login form component. Open it in your editor next. Call the window.location.reload function at the end of the login method. Let's give things a test. If you're already logged in, clear the storage. then log in. After successfully logging in, the page will refresh. Check the View Developer Tools to check the state. The state property was mutated, indicating the user was logged in. Alright, let's move on to logging the user out. We're going to modify the navigation menu to add a link for logging the user out. We'll open the header component file in our editor. This component is where we placed the navigation menu. We'll search for the links by looking for an unordered list element. There's a comment above them that says primary navigation. We want to hide the login link if the user is logged in. We're going to apply the vif directive to the list element surrounding the link. We're going to check if the user is authenticated in the state. We don't have access to this state at the moment. We'll need to import the appropriate mapping functions. Scroll down to the script block. We're already importing the map stores function from the Pinia package. This function is not limited to mapping a single store. We can map multiple stores. Let's import the user store. Next, inside the map stores function, pass in the user store. Scroll back to the link in the template. Inside the vif directive, we'll pass in the user logged in state property for the condition. We're going to add the not operator before the condition. We want to check if this evaluates to false. If it does, we'll render the login link. Otherwise, it'll be hidden. The link next to this one is the manage link. We'll render it if the user is logged in. We'll attach the velse directive to the next list item to get this effect. The manage link will redirect users to a page that will allow them to manage their songs. We haven't created that page, but we will soon. For now, toggling its visibility will suffice. There's one more link we'll want to add. However, we face one issue. We can't apply the velse directive multiple times. Luckily, there's a simple solution for getting around this. We'll surround the list item element for the manage link with the template tag. Next, we can move the velse directive from the list item element to the template tag. By wrapping it with the template tags, we'll be able to render multiple list items. We'll copy the list item element for the manage link. We'll change the inner text to say log out. Let's check if this works. If you're logged in, you will see the manage and log out links in the navigation menu. The login link is hidden from view. So far, so good. The next step is to make the logout link functional. Firebase offers a simple method for logging the user out. First, we'll open the store file in our editors. Since we're writing logic that'll affect the state, we'll place the code in an action. Inside the actions object, add a function called signout. Be sure to add the async keyword before the function definition. Signing the user out is an asynchronous task. Inside the function, we're going to call the following method: await auth.signout. Firebase provides a method called signout, which will sign the user out of the system. It's going to clear the credentials from the storage. Firebase will revoke the token that's stored internally if the user attempts to hang on to it. This single method will take care of everything on the client and server. After logging out from Firebase, we can update the state. After the signout function, set the this.userLoggedIn state property to false. The action function is ready. Let's call it from the header component. We'll head on over to it. The very last step is to call the signout function if the logout link is clicked. Scroll to the template block. On the anchor element for the logout link, listen for the click event with the prevent modifier. The prevent modifier will stop the default behavior. If this event is triggered, we'll want to call the signout method we mapped. This will complete the logout functionality. It's a very straightforward process. Let's test the logout functionality in the browser. If I were to press the logout link, we would almost immediately see the login link again. Let's check if things are clear in the developer tools. First, we'll check with the state. As you can see, the user logged in state property has been set to false. Alright, let's check the storage next. We want to make sure Firebase deleted the user's token and their information. We'll navigate to the application panel. On the sidebar, inspect the storage under indexed DB. We'll find that the values stored by Firebase are gone. The signout method we called in the action will clear the storage for us. Just to make sure, let's try refreshing the page. Despite refreshing the page, the application won't log us in. We'll continue to see the login links like we did before. Perfect. We've successfully logged the user out of the application. In this lecture, we're going to explore what JSON Web Tokens are. We're finished with the authentication system for the application. One word I've brought up often is the word token. What are tokens? How do they work? These are the questions I want to answer in this lecture. Let's start with what web tokens are. Tokens are encoded strings that hold your data. Plain and simple. If you were to look at a token, all you would see is random gibberish. Despite its appearance, it's one of the most effective and popular methods for authenticating a user. They're used to transport data between the client and the server. One of the most significant advantages of tokens is that they're digitally signed. Let's say a hacker is able to get a hold of one. They may be able to read the data, but they won't be able to make changes to it. Any changes to the token will automatically invalidate it. This mechanism limits the damages one can do if they steal a token. In our case, tokens are signed by Firebase. We don't have to worry about encoding or decoding tokens. The SDK handles most of this process. Even if a hacker is able to grab a token, they'll have a hard time decoding the data unless they have the signature. On top of that, tokens expire in an hour. This system makes it undesirable for most malicious users. We've learned what tokens are. Let's move on to discussing how tokens are created. Tokens are generally generated on the back end. It's not something you would create on the front end, but you can if you want to. In the resource section of this lecture, I provide a link to the official JSON Web Token site. It has every resource you'd ever want on tokens. Web tokens aren't just for JavaScript. You can use it with almost any programming language available. If we were to scroll down, we'd find a playground for creating tokens. Tokens are broken down into 3 sections. The first section is the header. This section is where we can store meta information about a token. It's an object with 2 properties. There's the algorithm and the type. The algorithm is the formula used to encode the web token. There's no official algorithm for web tokens. You can use any of the hundreds of algorithms out there. The type is the type of token being created. 99% of the time, this will be set to JWT for JSON Web Tokens. The next section is the payload. This is the contents of the web token. It's an object filled with data. You can store any type of data you'd like, from addresses to passwords. There's no limit as to how much data can be stored in a token. This scalability is another advantage to using tokens. They're encoded, which will compact them into a small string. This compactness allows for a lot of data to be transferred without having to worry about overloading the request. The last section is the signature. The signature is used to verify the contents of the web token. The signature is the most critical part of a token. It's calculated with a few things. First, the header is encoded with base 64. After it, a dot is added. This is to separate the next part of the signature, which is the payload. The payload is also encoded with base 64. One last dot is added to the last part of the signature. This value is the most important part, which is the secret key. The secret key can be anything you want. The playground allows you to modify it. Suppose you were to change it. The encoded token to the left changes as well. As an extra measure, you do have the option of encoding it with base 64. In the end, every part is concatenated together. The concatenated string is hashed with the algorithm you set in the header. The result is added to the token. We have the opportunity to play around with this. Let's do so. Inside the payload, we're going to add a property called admin. We'll set it to false. We're creating a property for determining if we have administrative permissions. In this example, I set the admin property to false to indicate I'm not an admin. Now let's say I'm a malicious user who's trying to become an admin. I would have to modify the token if I'd want to do that. From what we've learned, we know that the middle section is where the payload data is. The playground highlights this for us by changing the text color to purple. I'll copy the encoded string that holds the payload data. After copying it, let's head over to base64decode.org. I'll provide a link to it in the resource section of this lecture. Paste the payload into the first box and decode it. This tool will give us access to the object that was decoded. We'll find that the admin property is still set to false. If I want to give myself admin permissions, I'll need to change this to true. Then I'll copy the entire object. At the very top of the site, I'm going to switch from decode to encode. I'll paste the object into the first box and encode it. We've given ourselves admin permissions. The last step is to update the token with the modified payload. Copy the payload into your clipboard. Then, we'll head back to the token playground. Inside the encoded string, we're going to replace the second section with the newly encoded string. This trick may look like it'll work, but it doesn't. Looking below, we'll receive an error stating that the signature is invalid. On the right side, you'll find that the payload was correctly decoded. It has the admin property set to true. The problem is that the payload and signature don't match. The signature is based on the payload. We'll need to update the signature if we want this to be a valid token. This is where the problem begins. In order to create a new signature, we'll need to know the secret. The problem is that I don't know what the secret is. I may know what the header, algorithm, and payload are, but without the secret, I will have a hard time creating a fake signature. Therefore, I'm unable to generate a fake token to fool the backend. The secret is considered the most crucial part of a token. Even if a hacker can decode everything, it can be hard to spoof a token without the secret. This topic leads us to one final concern. Is it possible to steal a token? The answer is yes. It's not uncommon for people to sign in online at public locations. You shouldn't do this, but it does happen. In these cases, someone can monitor the network and steal a token. This issue is not exclusive to tokens. Anything that needs to be sent between the client and server can be stolen. This includes passwords, cookies, sessions, etc. So how do we prevent hackers from doing so? The answer is quite simple: SSL. SSL or TLS is a standard for encrypting data when it's sent between the client and server. Installing a certificate is a job handled by backend developers. Therefore, not much of a concern for us. There are hosting services that offer SSL certificates along with installation. It's vital that you have SSL enabled on your application. You'll have to anyway because Google will penalize you for not having an SSL certificate. It's a standard to have one nowadays. I always recommend grabbing one. There are premium certificates, but free certificates will do just fine. There isn't an excuse not to use one. I won't be going over how to install a certificate because it's beyond this course's scope. It's more of a back-end sort of thing. We're finished with talking about tokens. They're a reliable method of transporting data between the client and the server. One last thing. I want to show you where you can find the token Firebase generates. In the application panel of the developer tools, navigate to the indexed DB storage. Under the table of values, select the Firebase Auth row. In the Value column, Firebase will store an object with information about the user. The property we're interested in is the STS Token Manager property. This property is where Firebase is storing the token for validating the user. It's accessible to you in case you ever need it.